So it is just like we did before, from index to logarithmic form, logarithmic to index form. Question number 1 says e raised to the power x is equals to 6. So changing it to logarithmic form, this becomes x is equals to log 6 to base e, which is understood that ln x is actually equal to log x to base e. So we can change it to ln 6. One thing. Other thing is you can now directly write it in this way. E raised to power x is equals to 6. X is equals to ln 6. Or if you use the power law, e raised to power x is equals to 6 and you apply ln on both sides. So e power x is equals to 6. So this x comes out as power law, and ln e is 1. ln e is equals to 1. So x is equals to ln 6. No matter how you do it, you always end up with the same answer. ln 6, ln 6, ln 6. And now you will just punch this number in your calculators. ln 6 is 1.79. So x is equals to 1.79. Look at question number 2a. 2a says ln x is equals to 2. Now this is logarithmic form. We'll change it into index form to make x the subject. So x is equals to e raised to power 2. Again, just punch in the number. E square is 7.39. And I've just noticed it said that leave your answer in exact form. So we'll leave our answer here as e square. X is equals to e square. Question 2d. Question number 2d says 2 ln 6x minus 2 is equals to 5. Now we are solving for x. So 2 goes there. ln 6x minus 2 is equals to 5 by 2. Now this e is coming on the other side. 6x minus 2 is equals to e raised to the power 2.5 or 5 by 2. 6x is equals to e raised to power 2.5 plus 2. X is equals to e raised to power 2.5 plus 2 by 6. Any issues? Look at question number 3. Solve the equations giving you answers in exact form. Question 3a part. E raised to the power 2x minus 8e raised to power x plus 12 is equals to 0. Now if you can see, we can make subject. Well, let's say y is equals to e raised to power x. We substitute it, and I can write y square minus 8y plus 12 is equals to 0. Now we'll solve this. So y square minus 6y minus 2y plus 12 is equals to 0. Take out y as common. So y minus 6 minus 2, y minus 6 is equals to 0. Y minus 2 first factor, y minus 6 second factor. Y is equals to 2 and y is equals to 6. So e raised to power x is equals to 2 and e raised to power x is equals to 6. Now this is index form. So when you change it into logarithmic form, this becomes x ln 2 and x is equals to ln 6. The question said leave this is it. Either you go directly or you apply log. This is where we applied log, this is where we went directly, and the last one was you apply ln on both sides. No matter how you do it, you end up with the same answer. ln is log with base e. So if you go like this, x is equals to log 2 to base e from index to logarithmic form, and then log to base e is understood that is ln. So I converted it directly. Like when you see this ln, you consider it log with base e. Look at this question C, 3C. It says ln x whole squared plus 2 ln x minus 15 is equals to 0. Now I'm substituting y is equals to ln x. So I can write y square plus 2y minus 15 is equals to 0. Going for midterm breaking, y square plus 5y minus 3y minus 15 is equals to 0. So y plus 5 minus 3, y plus 5, y minus 3 times so y plus 5, y is equals to 3 and y is equals to negative 5. Now we started with this ln x and see ln x is equals to 3 and ln x is equals to minus 5. So when you change it to index form, this becomes e raised to power 3 and this becomes e raised to power minus 5. And this is your answer. Once you apply the laws of logarithm, yes, Mohammed? If we have ln x is equals to 4, yes, that will be e raised to power 4. Basically, ln x is equals to 4. This is understood that it is log x to base e is equals to 4. Now when you change this logarithmic to index form, it becomes e raised to power 4. Question number 4. It says e raised to power x plus 12e minus x is equals to 7. So what should we substitute? Y is equals to e to the power of x. So I can write y plus 12 over y is equals to 7. Now I'm multiplying the whole equation with y. This becomes y square plus 12 is equals to 7y. Rearranging the equation, y square minus 7y plus 12 is equals to 0. Midterm breaking, 3y minus 4y plus 12, y minus 3, y minus 3, y minus 4 times y minus 3, and y is equals to 4, y is equals to 3. And we knew e raised to power x is equals to 4 and e raised to power x is equals to 3. So x is equals to ln 4 and x is equals to ln 3 in exact form. Yeah, here is it clear? Okay. Please try this question 5a. I'll write it here. 5a is ln bracket 8x minus 3 is equals to 2. Solve for x, giving your answer in exact form. Say that again. E8. I don't think so. This is logarithmic form. First, we'll change it into index form. Get rid of this ln sign. When this goes there, 8x minus 3 is equals to e squared. E squared plus 3. Then x is equals to e square plus 3 over 8. Let's have a look at this D part. Question 5D says ln x minus 1 whole square is equals to 4. Before we start this question, ln x square and ln x whole square are two different things, okay? These are not same. So if this is ln x minus 1 whole square is equals to 4, we take square root on both sides. This becomes ln x minus 1 is equals to 2 and ln x minus 1 is equals to minus 2. Ln x is equals to 3, x is equals to e power 3. Ln x is equals to minus 1, x is equals to e raised to power minus 1 and 1 over e. Why are these two not same? Ln x square and ln x whole square. Because in case of ln x square, we can write 2 ln x. And in the other case, it stays as it is. This 2 cannot come down. This stays there. Getting it? Okay, now we have this sketching part, linear. We also know this exercise as linear law in additional mathematics. So let me just pick up the equation. If you see at this equation, in example 20, equation is P equals AB par T. And it says the graph represents the growth of the population of bacteria P over T hours. So P is on y-axis and T is on x-axis. So this is P and this is T. When you will draw this equation with using P and T, you will not get a straight line. But if you apply logarithms to this, this becomes log of P is equals to log of AB par T. Now what can we write? Log of P is equals to log of, these are being multiplied, multiplied means addition sign, log of B power T. Now in next step, this T is going to come down and becomes log of P is equals to log of A plus T log of D. If you remember this equation, y equals mx plus c, c was the y-intercept, m was the gradient. Whereas we know y and x, in this case we know p is somehow related to y and t is somehow related to x. So I'm just rearranging it. Log of p is equals to t log of b plus log of a. Now have a look at this, y equals mx plus c. What am I doing here? Capital Y is equals to mx plus c. Now capital Y is actually equals to log p. That means we will draw log p on y-axis. Capital X is equals to small t. So we'll draw it against t. And whatever is with x, that is the gradient. So gradient is log of b and log a is the y-intercept. So when we sketch this line, this y-intercept is log of a, x stays the gradient is basically log b, because the question stated that we are drawing a graph between P and T. So B is basically the constant. Gradient of this line will be log of B. So we have everything y equals mx plus c. We know our y is log B, our gradient is log B, x is t, and y-intercept is log a. And it would result in a straight line. For example, this very equation s is equals to 4 times 7 power x. Exercise 14H, question 1. S is equals to 4 into 7 raised to power x. First part says show that it turns into this. So we can see we have to apply logarithms. So we apply log on both sides. This becomes log of s is equals to, may I directly write as log of 4 plus log of 7 raised to power x, because I know they're being multiplied in form of logarithms. We'll use an addition sign. If they were being divided, we would use negative sign. So log of s is equals to log of 4, and using power law, this x comes down, x log 7. And it is shown. Then it says the straight line graph of log of s. It says log of s against x. Log of s against x is plotted. Write down the gradient and the value of intercept. So gradient and intercept. So if we look at our equation, I know y is equals to mx plus c. So gradient and y-intercept Let me write it in reverse form because this is our m. Log 7 is the gradient. Gradient is log 7. Why so? Because on x-axis we have x. Yeah, anything with x is log, the gradient. And y-intercept is log of 4. Those souls who have practiced the previous task will feel confident. Look at question number 3. The data below follows a trend of the form y is equals to ax raised to the power n, where a and n are constants. Copy and complete the table of values of log x and log y, giving you answer to 2 decimal places. So it is just use of machine. We'll punch in and get our values. Let's do it quickly. So log of 33.3 is 1.52. Log of 0.09 is negative 0. Sorry, why am I taking 0.9? 64.3. Log of 64.3 is 1.81, rounded to 2 decimal places, and log of 87.9 is 1.94, up to 2 decimal places. Plot the graph of log y against log x. Now in this case, log y, log x, we already have these points, so I can see log x is increasing, log y is also increasing, and let me say this looks like this. Use your graph to estimate the value of a and n. So what a and n are, if I write this equation in logarithmic form, this will look like log y is equals to log a plus n log x. So this box right here is y, this box is c, log x is x, and this n is the gradient. So use your graph to estimate the value of a. A, basically from our graph we'll see the y-intercept, this value, whatever it is. Let me say this is 0.47, just an example. Because I don't have graph paper right now, so let me consider. So what I'll do is I'll write log a, because we know log a is the y-intercept, and we'll copy it from the graph, is equals to any value. So log a is equals to whatever the value will be, and we can solve for a. Are you getting this thing? And from the graph we can choose two values and find the gradient and say this is m. The gradient is n. This was one way. The other way is you already have these points. We can use these points to find the gradient. One thing. And once you have the gradient, you can use this equation y is equals to mx plus c. You know this value. Choose this set. You know the value of log y. You know the value of log x. You know what the y-intercept is. You know what the gradient is. So you can also use this equation. Let me do this algebraically right now because of the absence of graph paper. So let me just write this. It got stuck. Why is it happening? right now. Okay, done. So log of x, log of y, I'm using these two values 0.48 against 0.7, 1.21 and 1.52, and my main equation was y is equals to ax raised to power n. Y is equals to ax raised to power n. Converting it into logarithmic form, log y is equals to log a plus n log x. So basically, if I use these values and find the gradient, so this is y2 minus y1 over x2 minus x1, and using calculator, this gives me 1.52 minus 1.21 divided by 0.7 minus 0.48. This gives me 31/22. I'm keeping it as it is because I've got the exact answer. So log y is equals to log a plus 31/22 log x. Any issue in gradient? I'm using this set. Log y is 1.21, log of a is unknown, plus 31/32, and log of x at that time is 0.48. I'm using this to find log a. So 31 divided by 22, sorry, that was 22. 31/22 multiplied with 0.48, 1.21 minus answer, and log of a is 0.5363, and the examiner, the question demanded value of a, so this is 10 raised to the power 0.53636. So 10 raised to the power answer, and that is 3.41. So demand of question was the gradient and value of a. And if we have to write it up to two decimal places, this would be 1.41 gradient and y-intercept. Probably this is the last thing in this chapter, and we've covered the entire book. Yes, one of the books, yes. Paper 1.